Hello, welcome everyone. We are here at Prefect Live. I'm Jeff Hale. I'm with Prefect, and Matthew Rockland is my guest today. And Matthew will be talking about Dask, a little bit about Coiled, a little bit about whatever else Matt wants to talk about today. And Matt's coming to us from Austin. So, Matt, do you want to tell us a little bit about who you are, what you do, how you found yourself here on the show today?
Sure. My name is Matt. I'm an open source software developer in Python for a long time. Most notably, I've worked on a project called Dask for parallel computing. We've been parallelizing Python since, 8 years ago. And then I think a substantial user group of Dask uses Prefect too. I think when Prefect first came out, one of the advantages is that it was built on Dask, it could do things like communicate between machines. So it's always been a really nice connection between the two technologies. We actually have a lot of Dask users who first started as Prefect users, not knowing what Dask was, and oh, what's this thing underneath the hood? And then they come over. So it's fun, always fun talking to Prefect folks.
Awesome, very cool. Yeah, it's cool now. The ecosystem of Python tools is just so huge, right? And someone comes in through lots of different avenues and they find a use case and they need to parallelize their workloads, and maybe they go in through Dask, or they come to Prefect first, or some other mechanism, and everyone kind of ends up a lot of places. So very interesting to see how it works out.
Mm-hmm. When we first started, it was like MPI or IPython parallel. And we were trying hard to get the world to care about Python in a business large scale data context. And now there's everything, right? It's actually really fun seeing the world move into Python wholesale. It's no longer this weird fringe language used by physicists. It's used by everybody. And so the game changes.
It's exciting in a time when there are maybe fracturing of other languages and other tools and other languages and frameworks. It's nice to see some kind of
we've always been fractured, Jeff. Python has always been fractured. That's the beauty of it, right? It's the crazy, bizarre model of things. We just embrace the chaos, which is different maybe from other approaches.
Yeah, it is true. There's certainly lots of different directions to go, but having at least some kind of common base place to come back to with the language is nice, and that involved for sure. Absolutely. Well, cool. Do you want to tell us about what's happening in Dask land and Coiled, and maybe give us a little demo for folks who want to get started?
Yeah, let's roll. Let me share my screen. Let's see. Yeah, so I've got some slides, got a couple of examples. I think if I just talk on my own without interruptions, probably 10 minutes, maybe 15. Hopefully people have questions and they redirect me to other stuff, because me talking about it is kind of boring. But yeah, so I work on Dask. Dask is a library for parallel computing. You've probably seen Dask before. It has a lovely dashboard. It has a lovely logo. It does a lot of parallelism. I also work at a company called Coiled, which is a company based around Dask. We're a Dask company. And so I'll talk a little bit about both. I like to start with an example that'll show both how Dask makes parallelism easy, kind of tries to fit into your workflow, and how Coiled makes infrastructure easy. What we found out is that lots of people liked Dask, they wanted to scale out, and then managing the cloud was hard. So those sort of the split between the two things. But let's see an example. I was hanging out with a colleague, Thomas Caswell, who maintains Matplotlib. And he told me anecdotally that someone told him that about 15% of scientific journal articles online use Matplotlib plot somewhere in the image. And so we wanted to figure that out. But it's 3 terabytes of data. And so we sat down and we wrote some for loops to try to process that data. It was too much data to process at once. And so we scaled up with Dask. So I'm going to do that with you here today. And we're going to recreate this plot that shows the use of this library Matplotlib, which is foundational to Python, and its use over time, which is a neat thing to see.
Very cool.
So, for example, all the data is actually available beautifully on S3. Archive is this academic publisher, and they've published all their data in open access on Amazon S3, and it's stored in these really janky tar files. And there's 5,000 of these really janky tar files. Thomas and I sat down and we wrote some janky Python code, which probably looks similar to what janky Python code you've written. And we run it on one of those directories. And this is going to like sit here for like 20 to 40 seconds, depending on the speed of my internet. I'm not going to get into the janky Python code, but the point is that it is janky. And also the point is that it's slow to run one of them. And what we find is we find a bunch of different PDFs and whether or not they contain matplotlib. And these PDFs have a weird naming convention. This is the year 2000, the month November. So in the year of November, month of November, year 2000, most of these are false, which is not surprising. 2011 was like not a good year for Python. So let's parallelize this. So I'm going to ask for 100 machines on the cloud. And this can take us a couple minutes to get those machines. And once I get those machines, I'm going to go and be able to run that same function on those 5,000 directories in a few minutes. And that's going to be fun. So this is sort of the promise of parallel computing, right? This is a situation that we're commonly in. We have a lot of data or a lot of work that we want to do. We do not have the computational resources locally to do all of that work. And so we want to rent machines, someone else's computers, probably Amazon or Google's or Microsoft's. We rent those machines for a brief period of time and then do some work and then give back those machines. But that renting process and the distributing the work is challenging. And so right now we're leveraging a technology called Coiled. And right now what it is doing is it is looking at my local software environment, it's packing up all my packages, shipping them to the cloud. It's in parallel asking for 100 machines. Those machines are coming up online right now. So I've rented them. They're now mine. I'm paying for them. They're installing Linux. That's about done right now. And now they're all in a state where they're installing Python and Dask and various other libraries that I've installed that I need for my processing. And I'm getting sort of a lot of nice feedback in this process, right? So I'm seeing the experience better. If you're used to interacting with cloud, you probably know this is like usually a painful experience. Once this is done, I'm just going to go back to my code again. I'm going to be back in sort of Python land, and we're going to do some computation. Now I've got a vamp for like a minute while this thing is finishing. I've got one worker that's installed. I've got 3, I've got 4, I've got 16. Great, my workers are coming up. Got all these assets coming in. And so what I'm gonna do next, once this is ready, once I get sort of 60, 70%, Coiled will just give me back control. Yeah, great. Now I'm gonna connect to that remote resource. It took about 2 minutes. I'm going to set up my little Dask environment here. I'm guessing that some of you have used Dask. My experience with Prefect users is like half have used Dask directly. But if not, what I'm doing here is I'm getting a bunch of these dashboard plots that I care about so that I can sort of understand my computation as it's running. I've connected my local Mac Mini up to that remote cluster. I'm going to run that extract function on all those 5,000 directories, and we're just going to wait till it finishes. And what we can see here is we get a nice little progress bar down in the lower right here saying I've finished 35 out of the 5,800 tasks. The chart at the top here is showing every horizontal line corresponds to one core in my cluster. I've got 200, 400 cores. And then every horizontal bar is one call to the extract function. It's one task that I've run. So I'm running this Python function 5,000 times, and I'm running it, in a parallelism of about 200 or 400. So that's running, and that'll take a few minutes. I'm actually going to sort of just move on, and we'll check back with the computation in a bit. But this is Dask, right? I got to write some Python code that took my existing Python code and my existing data and run it in parallel. And then this appears Coiled. I got to sort of get resources pretty quickly and pretty easily, and that was convenient. And what that means is that my janky Python code, right, this stuff, and the problem that I had, too many directories, is all just pretty easy to handle. I get to sort of move past this hurdle, this barrier of interacting with cloud, and jump back directly to productivity. So while that bakes, I'll switch back to slides for a few minutes. So what did we like about doing all of that? Some things, it was fast and informative. I had like cloud access in a couple of minutes. That was neat. It also like told me what was going on. At Coiled and Dask, we really care about user feedback. Often distributed computers are hard, parallelism is hard, and it's frustrating. if you don't know what's going on. We've actually found there's a really big psychological benefit just to giving feedback. Installation is really easy. You can like pip install Coil to get on your laptop. And then Coil itself was like moving all of my libraries over automatically, which is really useful. Everything just worked. There's some other magic service elsewhere that is managing all my cloud resources for me. That's this service like Prefect Cloud, but for Dask. And then most importantly, it was really intuitive to interleave with my existing code, right? If I've got basic sequential code like this, I can parallelize it like this. And that shift, that easy shift from where we are today to where we want to be at scale without changing everything, that's really important. And this is where I think Dask has really won hearts and minds. It is easy to interleave into basic parallel for loopy code, or also into pandas code. There's things like Dask data frame which replicate pandas, or lots more. So I'll get into that a little bit. Before I do that, how is our computation doing? Right, we're about halfway through. Right, so we'll come back in a few more minutes. So, what else can Dask do? So let's talk a little bit about Dask, and then we'll talk about Coiled afterwards. So we've seen parallel for loopy code. Here we're doing, in our archive matplotlib example, we're doing just embarrassingly parallel work. We're taking a bunch of inputs, processing them, getting a bunch of outputs. This is probably like 80% of work. Dask does it very easily. There's lots of easy APIs for this. Dask also does really complex for loopy code. You can do arbitrary for loops. These things can be fully dynamic. Dask is very, very powerful. Also very useful if you're in a more advanced industry. Dask data frame leverages libraries like pandas and Arrow to do parallelism at scale. Or data frame computation at scale. Dask can be kind of like a Spark replacement. So you can, read data from Parquet or from Snowflake. You can do feature engineering. You can train XGBoost models. You can do hyperparameter optimization with PyTorch. There's lots of sort of standard data processing tasks we like doing, which are very commonly done with Dask. Dask, actually, it's interesting. Dask also used a lot, not with data frame computing, but with arrays. So think like brain scans, 3-dimensional images. Climate scientists, most climate scientists, meteorologists today use Dask if they're using Python. Satellite imagery. This is also a really common use case. And then just weird, wacky stuff, which including Prefect, right? So tools like XGBoost, LightGBM, Optuna, Xarray, and Prefect all have native Dask integrations. If you go look on PyPI today and search for Dask, there are like 200 or 300 different packages integrating Dask with MongoDB or Elasticsearch or what have you. So Dask is sort of very endemic throughout the PyData ecosystem. Let's go check again, see how our progress is doing. Ooh, we're almost done.
Matt, is this a good time to jump in with a question here?
Go for it.
Awesome. So we have a question here. Do you see a lot of people needing just Dask data frames, or are most Dask users also diving deep into Dask bags and maybe some of these more like elementary structures, more basic structures? Yeah,
that's a great question. Most users don't use a single API. They use a few. Let me actually bring up, this is kind of old, it's from 2021. We sent out a survey to folks and asked them, what APIs do you use? And if we actually dig into the data, you'll see there's a lot of overlap. But this will show you some of the APIs and their relative use, at least among folks who answer a survey, which is pretty biased. What we'll often find is someone will use something like Dask data frame and Dask delayed, right? The fact that you can switch between these two is really useful. Often you want to use Dask data frame to like read from Parquet and do a shuffle or a sort. But then you got something that's more complicated. It doesn't really fit into a data frame abstraction. And so you take that Parquet data and you sort of break out into a more custom API where you do for loopy code. Then you come back into data frame world. So that's a really common interaction. But also just like, here's a distribution of use cases. Prefect is down here. This is a couple years old. I'll bet the Prefect usage is up a bit more. But yeah, hopefully that answers your question.
Yeah, that's great. Second question here, where can I get these notebook extensions? Is there, are there any magic extensions going on there? I think these are pretty straightforward, right?
Yeah, so this is the Dask Lab extension. It is hard for me to both engage with the chat. Can I ask you, Jeff, to put this back in the chat if that exists?
Yep.
Yeah, so Dask has like a strong history with Jupyter. A lot of, actually, some of the original Jupyter core maintainers helped with Dask. And so Ian Rose, who maintains Dask, who maintains Jupyter Lab, also a Dask maintainer, built this connection. So if you install this, you'll get that interaction. Yeah. Other questions?
I think that's all for right now. But keep them coming, folks. We'll raise some good times. Thank you.
Yeah. There's like a decade of Dask materials. Most questions you can ask, I've got at my hands, ready fingertips answers. Anyway, I'm just going to go quickly through. We've got this data now. We've done the hard part. We've processed all of these tar files on S3. We should just close that cluster down now, and we're going to stop paying money to Amazon. And in the meantime, we now have small data, and we can just use pandas. And we'll do a little bit of processing, and we can now get a chart, which will hopefully, here we go. This is the chart that I made. Thomas Caswell on the Matplotlib guy says, Matt, that's a bad chart. Here's a better chart. And so here's our chart. Right, we made that image, and we see that Matplotlib has increased in use really predictably over the years, and it's now at about 17%, which is incredible. And this is actually really valuable for Thomas, right? He can go to the NSF, he can go to funding agencies and say, look, science uses Matplotlib. There's no slowdown in this usage. Give us money to have one person fund it, right? So this is of like high value. We've gone over the challenge of scale to get back to producing value. So, okay, I'm gonna go ahead. Jeff, you unmuted. I'm guessing you have a question. No?
I did. I just thought that was a really nice phrasing there of overcoming the challenge of scale to keep delivering value. To paraphrase, I think that was
yeah, absolutely.
It's like that.
I mean, no one wants to use Dask. No one wants to use like a shovel, right? You use a shovel because you have to move something, but like you don't really like enjoy the activity of shoveling. Same with Prefect. Like, forgive me, but like if you don't need Prefect, don't use Prefect. Prefect is there to get you over problems so you can do your real job again. Most of PyData operates in that way. We want to not exist. We exist from need.
Right. So, use it when you need it.
Yeah. So that's Dask. I'll talk about Coil a little bit. So what we found is that lots of folks, including lots of Prefect users, really liked Dask, and they loved it on their local machine, but they wanted to just deploy it in a more robust way, and that was hard. It's like a totally different skill set. And so we made a platform to deploy Dask in a really nice way, and that's what I was using earlier with Coiled. I'll give a couple of like brief things about that, and there are some blog posts here that that I'll put in the chat when we're done. You can go to these slides, and you can get all these links. So Coiled provides cloud infrastructure for systems like Dask. It provides like a very rock solid deployment. It is mature in all the ways you want it to be mature. We also actually care a lot about efficiency. So it's very cheap by default. We find that usage, there's a variety of like tricks that we can do to make things cheaper for folks, which we enjoy. A lot of us are very much efficiency nerds at heart. It's highly observable. We care a lot about tracking usage, and we care a lot about managing users. So let's jump into another example, unless there's other questions.
We do have one question here. I'll show this on stream also. Without Coiled, does Dask simply parallelize across all the local system's CPU cores? Is it multi-threading?
Yes. So you can deploy Dask in many different ways. You can deploy Dask if you just like, if I just like import Dask and don't create any kind of client or cluster, then it'll run a local thread pool. And that's a fine way of using Dask. It's probably how most people use Dask. That can run on threads, that can run on processes, you can run on some mix of them. If you got 16 cores, you can have 8 processes of 2 cores each, something like that. You can also deploy Dask on Kubernetes or on HPC job schedulers or on any system that manages machines. Coiled is one technology that allows you to deploy on the cloud, but there are many different ways to deploy Dask. A good example of that, if you go to docs.dask.org and you look for a deployment, there's a lot of good materials here about how to deploy Dask in different ways. That being said, if you're on the cloud, like I'm biased because I work for this company, but it's a very nice way to deploy Dask coiled. So I'm using here. So I'm playing with a cool data set I want to actually pitch for a second. So this is the New York City taxicab data set, but it's a different variant. The New York City taxicab data set has been around for a very long time. It shows you every ride in the city of New York. This one is actually not the yellow cabs though. It is Uber and Lyft. This prefix HVF is the high volume for hire vehicle services. And there are 5 of them: Uber, Lyft, I think Via, there's a couple of others. But it's actually really cool. This data set hasn't been played with at all. And it's neat. I think, for example, like DF, I think there's a base passenger fare. Yeah. Let's go see how much money we all spent in the last year in maybe billions. This is using not the like parallel for loop part of Dask. It's using Dask data frame, which is more like a Spark replacement or a Pandas at scale. And we get to ask Pandas-like questions and get out answers really quickly. We spent about $12 to $13 billion on Uber and Lyft over the last few years. Like, it's sort of a neat data set to play with. So if there's other questions, we just switch to questions. If not, I'm just gonna like have fun interrogating this data set with folks.
Yeah, I think interrogate away. If folks have questions, keep dropping them in the chat.
Yeah. So one of my, so actually, I think I was looking at, there's a tips. Yeah, tips. And I was actually curious, like, what the ratio was between the passenger fare, not tips. There's like, so there's a driver pay. Just get the columns list here. So there's driver pay, and I was curious what the ratio was. Like, how generous are Uber and Lyft? Are drivers getting half? Are they getting 100%? Actually, it's not terrible. They get actually like the majority of the base pay. And if you go look at tips, it's like, it's interesting. Let's actually go look at that. So here's a question for the audience. What do you think the average of tips is going to be? What fraction of rides will be tipped? Jeff, I'll actually ask you, do you think it's gonna be 80% of rides are tipped, 20% of rides are tipped? When you get out of an Uber, do you hit the tip button or do you not hit the tip button? What do most New Yorkers do?
And then you get the reminders, and if you don't, like, you intend to, do you? I'm gonna say it's about 70% of the time it's tipped.
Okay.
2/3, 66, or 67.
If folks want to put
we had a 40%, Jack P says here. Other folks, feel free to jump in with estimates.
Yeah. We can also break this down by Uber and Lyft. There's a slight difference, which is fun.
Oh yeah, see if there's a difference.
So let's go check it out. So tips, non-zero, mean, it's like straight up Pandas code, 15%. Right, so 15% of New Yorkers tip. When I don't tip, I now feel way better not tipping, and that's terrible not to tip. Maybe it's not terrible. No one tips, it turns out, right? It's not 70%, it's 15%. I think there's this column license number. I think if we go and look at that, I think this
John
will...
says he tips during the ride, so he doesn't have to think about it afterwards. That's clever. There you go.
And generous. So I think if we look at these numbers, I think these correlate to Uber and Lyft, right? So there's like, I don't know, 4 million, 48, 46 million that are with this number 3. I'm guessing that's Uber. I'm guessing this is Lyft. And so we can go ahead and let's make a tipped column, which is df.tips is non-zero. Let's df.group by this df.hvfhs license number .tipped .mean, right? And I'm just typing in normal Pandas code. And what's cool is on the right, you can see how Dask is breaking down what I wrote into lots of little Python functions that are doing little tiny bits of work. And it's giving us this result. And we can see here the sort of the ratio of tips, right? And so we see that looks like this is probably, we're guessing Uber because we think Uber is the most likely, most common. And Uber drivers are tipping about 14%. And then, 05, it's probably Lyft, the second most popular, it's about 19%. And that kind of tracks what we think about Uber and Lyft drivers. Lyft is like kind of more driver friendly. Anyway, it's a fun data set. If folks want to, you can go to mrocklin/Dask tutorial. We'll upload this in the main Dask tutorial if you want. But this is all sitting here in this notebook. If you go and play with it, just for fun.
Awesome. Got a question here for you, this is not a question, but it is worth noting. This is maybe a commendation. The Coiled maintains the Dask Snowflake library, which is really amazing for reading data from Snowflake directly into Dask data frames in parallel. So kudos is what's being given there, I think, by Radbert.
Maybe, or that person works for Snowflake. It's one of those two things. I don't know which one of those are, but yeah. So I mean, this is a good point, right? Dask connects to lots of different technologies, and it connects in an easy way. And so if you work with some technology in Python, and you want to use that technology with Dask, there is probably like an existing connection for that technology. People often ask, what are the difference between Dask and Spark? This is a big difference, right? Dask very much was built with the sort of like Python community in the sort of more like the bazaar or collaborative mentality. And so it's kind of chaotic. And there's hundreds of different Dask packages that are all evolving in different ways. At Coiled, we have a lot of customers who use Dask and Snowflake together. We tend to attract more corporate customers, and Snowflake tends to be pretty commonly used in corporations. And so we have built and maintained a little Snowflake connector, which actually, it's a nice piece of technology. It was built with Snowflake. But there's many things like this. And so if you want to read some bespoke file format, it probably exists. If you want to scale on some bespoke cluster manager, it probably exists. So again, maybe like a final note is that Dask is very much designed around making, I'll go to the very top here, right? Dask is designed to make parallelism easy so that you can do your job better without thinking too much about parallel algorithms. And Coiled is designed to make infrastructure easy. We're designed so that you don't have to worry about managing cloud or tracking down errant ghost clusters or managing users. And those combination ends up allowing us to do pretty interesting analyses in pretty short time without a whole lot of knowledge. So we're really about sort of empowering everybody to do their best work with minimal fuss. And we've seen a couple of examples of getting interesting answers while a lot of complexity is happening in the background and being handled for us.
Awesome. I just shared your GitHub repo or GitHub overall account there. If people want to try to find out what's going on, and I know they can, from there you can access what they saw here today. Got a question here. Small question regarding Coiled, and especially how it is deployed behind the scene. You wrote a blog post about switching to Kubernetes. Quote, Kubernetes is fantastic and I often recommend it, but I've run into enough downstream pain that is no longer my default recommendation. I guess the implication here is perhaps if you want to talk about that at all and maybe what your default recommendation is.
Yeah, sure. I'm actually trying to put a link in the chat. I don't seem to be able to. If you can enable that for me somehow, Jeff, let me know. Yeah, so Coiled, so right, I've deployed Dask and Kubernetes dozens, hundreds of times. Don't worry about it, Jeff. If you can't do the chat thing, that's fine.
Yeah, just email it to me. I'll put it to everyone.
And Kubernetes is fantastic, especially if you want to maintain many different systems all running at once, and you have the experience in-house to maintain Kubernetes. In Coiled, we wanted to very quickly spin up clusters for users in lots of different accounts. We cared about doing one thing really well. And we found that actually interacting with native cloud APIs just was simpler. And so when I asked for machines, we use, on AWS, we use EC2 fleets, which we found is the most effective. And that just makes us really flexible, right? We can do things like, maybe you want to use spot instances. So we'll take as many spot as we can across the best availability zone, but backfill with on-demand instances if there's not spot available, right? And there's really interesting things that we can do by talking to the cloud directly, that if we needed to interact through Kubernetes, there'd be an interesting translation layer. Kubernetes is an amazing translator, but if you just really want to get to the other side pretty quickly, it's nice not having that translation in the middle. So yeah, we haven't looked back. Non-Kubernetes has been ideal if you're in the sort of cloud SaaS space. The blog posts, why we decided to skip Kubernetes is a good example of the things why we like and don't like Kubernetes, if folks are interested.
Awesome. Matt, this has been fantastic. Thank you so much for coming on the show, and thank you everyone for your questions and participating, and look forward to working together more in the future. So
Yeah.
thank you.
Thanks, everyone.
Thanks, everyone. Have a good one. Take care.